Hello again, everyone. Today's lesson, we're going to look at a concept called future value and present value. Now, this actually isn't much different from what we've been doing before, but for some reason in finance scenarios, they decide to start using new terms for something we already know. I am probably going to be relating to some of these things with the words that we're already used to, but I'll try to let you know when certain textbooks will use these two terms instead of the ones that we already know. And you'll see what I mean with the examples that are about to follow. So we already know the equation for compound interest, right? The compound interest formula is A is equal to P times 1 plus I to the N. Well, the thing is, why future value and present value? Well, the amount that you're getting can be considered a future amount of money. So I have actually seen formulas written like this for the same formula. So the future value of an investment is equal to the principal, but you can consider the principal as being the amount of money you're investing today, which we call the present value sometimes. So you will actually see some formulas written like this in financial textbooks or financial units of certain textbooks. Now, I personally don't like this way of writing the formula because FV to some students might actually look like two separate variables of F times V multiplying each other, and PV same thing, okay? So I never have used these versions of the equations, even if the textbooks use them. But all I'm trying to get you to see here is that it's the exact same formula with just new words basically used to represent the final amount and the principal. All right. So if you ever hear the word present value, the present value is just what would be the principal of the loan that you would invest today to end up with a certain amount at the end. Okay. And like I said, when we get into the actual examples, this probably will start to make a lot more sense. So the thing about this section is it brings up an interesting question, and it may be actually a question that's more interesting than the one for just calculating a final amount. One thing that a lot of people need to know sometimes is I want to invest a certain amount of money today so that I end up with the amount of money I need later on. So for instance, a lot of you are preparing to go to college. If by chance you ended up having a certain amount of money, either through, it could be multiple different things. It could be an inheritance. It could be a windfall of money through a lottery or something. Let's say you wanted to know how much money would you have to invest right now to cover your first year's tuition. So let's say your first year's tuition is, I don't know, $3,000. How much money would you have to invest today? And let's pretend that we're all in grade 11 and we've got another year to go before you have to go to college. In that year, how much money would you have to invest today to end up with that $4,000 or $3,000, that you need for your tuition? And it would be less, right? Because your interest would bring you up to the amount that you need. So you'd have to invest slightly less money in the bank or in an investment to be able to end up with the amount of money you need to go to your post-secondary education. So it's a slightly more, it can be a slightly more interesting question because it's a question that often we will have. So for instance, you want to buy a car in 5 years. Well, if you were investing a certain amount of money today to buy a car that was $15,000, how much would that have to be depending on the interest rate of whatever investment you're going to be using? So how do we work with questions like that? So let's look at an example to get us started. Jody wants to invest enough money today to have $3,200 for tuition when she goes to college in 2 years. If she invests at 4% per annum, compounded monthly, how much does she have to invest? So let's take a look at what are the amounts of money, or the amounts of, what are the different variables given to us, and what do we need to find, okay? So She wants to invest enough money today to have $3,200 in the bank. So if we think of our formula, A is equal to P times 1 plus I to the N, P is how much money we'd invest today, right? That's how much money you put in the bank. Like if you think of all our tables that we did recently, those tables always started at 0 years, and P was that zero amount, all right? But we don't know that here. That's what they're asking us to calculate. They're saying we don't know the original amount, but what do we know? What is this 3,200 in this case? Well, this 3,200 is actually our final amount in this case. So we actually know the final amount as a quantity that's given to us. We don't know the original amount. And that's what present value means. Okay? So it's kind of nice that principal and present value both start with a P, so it helps you to see what you're actually, trying to calculate here. So we're looking for our P value. Well, how do we find our P value? We need to rearrange this equation to get P all by itself. So we need to isolate P. And that becomes just a basic algebra scenario. Now you're going to see in a second that unfortunately finance textbooks usually make this a little bit more complicated than it needs to be. But it really is not that difficult to do. I mean, we've seen algebra questions like this before. How do we isolate a variable? Well, we isolate a variable by getting rid of the stuff that we need to get rid of to get it all by itself. And we do that by using opposite operations. Well, this is a multiplication here. And it's multiplying this entire thing. So that's all one thing. It's a bracketed value with a power of n. So that's all considered to be one thing. So we just need to bring that whole thing over to the other side of the equation. That's going to look like this. We're going to have a division. The opposite of a multiplication is a division. And now we've isolated our present value or our principal. And that's it. And then you just put in all the values. And I and n are going to be calculated the exact same way we've been doing for all of the other scenarios. And we'll continue this question in a second. But I'm just trying to get you to start thinking about this as just a regular math problem. You're just isolating a variable. So you're moving 1 plus I to the n over to the other side, and because it's multiplying on the right, it's going to divide on the left. And I'm sighing here because here's where things get a little bit tricky. Textbooks, especially in the past, it was difficult to format formulas like this with the line separating an above and a below part, or numerator and denominator of a fraction. So they didn't want to write it like that. And they wanted everything to be in line, like something similar to this, like all one line of things side by side. Now, we actually do know how to take a fraction that has a power and write it flipped. We've seen this in the exponent laws quite a little time ago, and that's with using a negative exponent. So I'm just going to jump right in and show you what I mean. These two things are exactly the same. You can use one or the other, all right? This one is used in textbooks simply because it's easier to type out. You don't have to format it as a fraction. But we do have the technology nowadays to be able to write out stuff like that without it being too difficult. The problem is, traditionally, because this has been the formula for some textbooks for so long, that that's the one that they use even today. I do not like this one at all. Okay, I do find that the negative exponent, even though you should be able to understand it, students understand a division a lot better than they understand a negative exponent. So I always use the division format of this formula. But your textbook And other textbooks in the future, if you do take any kind of finance questions, may show you the equation like this. Okay? They may also show the equation like this. Present value is equal to future value times 1 plus I to the negative n. Because they might use the present value and future value variables that I showed you on the previous page. Okay? But my preference is to use this version of the formula. Okay? So that is my preference. That's the one I'm going to use. I strongly believe that it is the best version of the formula. But you do need to understand that if I'm talking about present value and future value, present value is your principal, future value is your amount. Okay? So all of that just to explain the different versions of the formula you might see. We're going to use the one in the box to answer the question in the example. Okay? So I am actually just going to rewrite the formula. Now, normally when you have a formula that has an isolated variable, mathematicians actually don't like to have the variable isolated on the right. Normally we will isolate it on the left. So we will use P is equal to A over 1 plus I to the power of n as our formula. Okay? So in our example, we have to still calculate our I and our n. So if you remember properly, the I is going to be related to your interest per year. Per annum just means per year, compounded monthly. So as before, I is equal to, I've already forgotten the percentage, 4% compounded monthly. So just a reminder, I'm going to repeat this often so that hopefully it really starts to sink in. If you're getting 4% per year, that's at the end of the year, all of your little interest payments throughout the year add up to 4%. But we're compounding it monthly, which means we get a small chunk of that 4% every month. So we have to divide 4% by 12. Now 4% is 0.04 divided by 12. And I have my calculator off screen here. I'm just going to calculate 0.04 divided by 12. And that gives us 0.0033. Okay? Now we need to calculate our n value. So I'm going to use blue for the n value. If we come up here, the n value is based on 2 years, but it's also affected by the compounding frequency. So let's remind ourselves of what n means. N means the number of interest payments over the life of the loan. So if you're going for 2 years, but you're getting paid monthly interest, that means you're getting 2 times 12 interest payments, which is 24 interest payments overall. So those are always the 2 first calculations that you're going to use. Now we can just put everything into our new formula. Okay? So our present value is equal to our amount, which was 3,200. So 3,200 divided by 1 plus our interest, which is 0.0033, all to the power of n, which is 24. And now we just have to type that into a calculator. Now I'm actually going to switch over to my calculator at this point so you can see how to type that in. So you go 3,200 divided by, open a bracket, 1 plus 0.0033, close the bracket, to the power of 24. And all of that can be typed in at once, and we end up with a number. Now, does it make sense to you that this number is smaller than 3,200? This should make sense because it's a present value. This is how much money we'd have to put in the bank today to end up with the $3,200. Okay? So that should make sense. So we're investing $2,956, oops, and 72 cents today. I'll just write this out as a sentence. Will get us, well, it's not us, sorry. What is the name of the person in this, Jody? We'll get Jody. Wow, I'm having a little bit of trouble writing here. Let me try this again. There we go. We'll get Jody $3,200 in 2 years. Okay. So the trickiest thing about these questions is reading the question and understanding what the question's asking. Okay? So if you see anything in a sentence that says something about wanting to invest money today to end up with a future amount, that's when you have to rearrange the equation to get P by itself. And your homework questions will hopefully get you used to that kind of language. Now, the real tricky thing is when you start mixing the stuff we've been doing before with this stuff. Can you tell the difference? So you start needing to be able to read questions properly and really understand what is being asked of me. Am I finding an amount later on by investing a number today? Or am I finding a number today to figure out how much I need to get a certain amount later on? Now, there is another scenario where this can come into play. Now, this is a pretty specific one. Another situation where you might end up seeing this is if ever you have a loan and you actually figure out a way that you'd like to pay the loan off early. Creditors are people who lend money out. And this could be a bank, but there are other creditors out there as well. There's like companies that you can go to and they'll lend you money, and usually the interest rate's pretty high. But if you want to pay off your loan early, what might happen is that creditor will say, okay, well, we'll sell your loan off to another creditor and they'll help you out. Now that creditor, basically what they're going to do is they're going to say, okay, well, we'll give you a higher interest rate, but we'll compound it less, or we'll give you a lower interest rate. Okay, it depends on how the creditor wants to help you out, because they want to make some money off of this as well. So like I said, very, very specific scenario, but it can happen, all right? So here's an example. John has a loan for $5,000 that is due in 4 years. He wants to pay off this debt early. A creditor will discount the loan at an interest rate of 8% per year compounded semi-annually. How much would the creditor be willing to accept today? So it's a little bit harder, and to tell you the honest truth, I find these questions a little bit hard to decipher as well, that this is actually a present value scenario, okay? Now, when I write out a present value scenario, I always start by writing out the original equation. And then I say, okay, I'm trying to find the principal here, so let's rearrange the formula. So we're going to send the 1 plus I to the power of n over to the other side. And once you get comfortable with this, if you could start isolating it so that it's on the on the left side. Okay, you don't technically have to do this step, but the higher you go, if you do take mathematics in post-secondary school especially, they will be starting to ask you to follow certain formats. So, you know, you isolated on the right here, the p value, but it really should be listed on the left. Okay, So we're isolating our present value. So and what's helping you see in the question that it's a present value question is the last part here that says accept today. Today is a present quantity. So we're asking what would it be today, all right? So let's calculate our I and our N. So our interest, actually let me use a color for that. I'm just going to use green for that. So what are our interest quantities? Well, we have 8% per year compounded semi-annually. Now, we've actually talked about different types of compounding frequencies, okay? So semi-annually means twice a year, which means we're going to be dividing 8% by 2. So 8% at the end of the year, but we're getting small chunks of it, so we're dividing it by 2. So that becomes 0.08 divided by 2, which is 0.04. Didn't even need my calculator for that one. For our N value, well, our N value, this is technically supposed to be a 4-year loan, okay? But it's compounded semi-annually. So even though we're paying it off today, the creditor is still using the 4 years, but is giving a deal maybe on the compounded semi-annually. Remember how we saw that the more often you compound, the higher the amount of money is? So instead of compounding monthly, this creditor has broken it down to compounded semi-annually, same amount of time, but that is technically giving John a bit of a deal on his loan, okay? So, 4 years semi-annually. We always multiply by our compounding frequency to find our N value, and that gives a number of 8, okay? So let's put all of our numbers into our present value formula now. P is equal to A. Now A is the $5,000. Divided by 1 plus our I, which is 0.04, all to the power of N. So we're going to use our calculator to do that. I'm just going to clear out the calculator here. So we're starting from scratch. Okay, so we've got 5,000 divided by bracket 1 plus 0.04 bracket to the power of 8. And that gives 3,653.45. So let's go back to our screen here. Oh, wrong color. So $3,653.45 is what John would have to pay back today. So John doesn't have to pay his $5,000, and we don't actually know, more information about this. How much of a discount? Well, we know it's a discount from 5,000, but if he had paid off the entire loan, how much interest would there have been, et cetera, et cetera. So, so John will pay $3,653.45 today instead of 5,000 in 4 years. Okay. So that's pretty much it for this lesson, besides reading homework questions and starting to understand all the language that's used in these kinds of questions. And I believe the homework will primarily be these kinds of questions, so you can start to really reinforce the difference between these ones and the ones we were doing before. So I will post the homework questions in the Google Classroom. As always, if you need extra help, you could always rewatch the videos first of all. And if if that doesn't help, then you can email me and ask me for help that way. Okay? Have a great day, everyone. We will see you soon.